Hello and welcome. Tonight, we're going to do something strange. Not dangerous, not daring, just strange. We're going to unravel time. Not time as a clock or a schedule, but time as a thing, an idea, a force, a rule that seems to run the universe while also making us late for dinner. You've probably thought about time before. Maybe in a line at the pharmacy, or during a meeting that should have been an email, or maybe you've glanced at the microwave and wondered why a minute feels so different, depending on whether you're waiting for food or standing in the hallway with someone you don't know very well. Time, as we know it, is slippery. It's something we experience constantly, yet can't touch, stop, see, or really agree on. But tonight, we won't try to master time. No, that would be too energetic. Tonight, we'll simply observe it, calmly, gently, like watching a river go by and not feeling the need to jump in. We'll take our time, ironically, to explore time, how it became a thing, why it exists in the form we recognize, and why it barely works half the time, especially when there's a time zone change involved. Before we start, please take a moment to like the video and subscribe if you like this kind of content. Your support truly means a lot to me. Also, let me know in the comments where you're tuning in from and what time it is for you right now. I'm genuinely interested in knowing who is joining us from around the world. So welcome. Settle in. Let your body melt into the mattress, or the pillow, or the couch, or wherever you've chosen to disintegrate tonight. Let your eyes get heavy. Let your thoughts loosen, because for the next couple of hours, we're not going to do anything fast. We're going to meander, like a sleepy particle in a slow current, through the story of time. Time, as you experience it now, is almost entirely artificial. Not fake, just invented, human-made, like calendars, or socks, or the concept of brunch. It's something we've built on top of reality to make sense of the universe, or at least to help us know when to feed the dog. Without it, we'd still have the sunrise and the seasons, but we wouldn't have 3:47 p.m., or quarterly reports, or something called Wednesday. Humanity invented time because we're obsessed with patterns. We like to name things, measure them, put them into boxes and grids and lists. So we took the swirling chaos of existence and decided, quite confidently, that it would now be organized into units. Hours, minutes, seconds, milliseconds, and even nanoseconds, just in case anyone wanted to panic at higher speeds. It's easy to forget how recent our concept of time really is. For most of human history, we didn't use clocks. We used the sun, the stars, the shadows, and our own hunger. Time was felt, not read. It was fluid. Morning happened when the sky got light. Dinner happened when it got dark. And meetings didn't happen. And even now, with atomic clocks and precision timekeeping down to billionths of a second, time remains imperfect. It drifts, it bends, it disagrees with itself depending on how fast you're going or how close you are to a black hole. And occasionally, we have to add leap seconds to keep it from falling apart. It's one of the only systems we have that includes scheduled confusion just to stay functional. But none of this bothers us too much, because time is convenient. Without it, we wouldn't know when the train leaves, or when the pizza place opens, or when to awkwardly wish someone a happy birthday on Facebook even though you haven't talked since 2016. Time gives us structure, it gives us coordination. It lets us agree that we'll all meet at 8 and then not show up until 8:11. Time gives us schedules, and schedules give us deadlines, and deadlines give us the feeling of productivity, or at least the illusion of it. In this way, time is not just a measurement, it's a permission slip. It allows us to do things, and to not do things, and to feel okay about both. But let's step back. Before the alarms and the meetings and the New Year countdowns, before the wristwatches and the train schedules and the 24-hour news cycle, time was simply change. One thing happening after another. Water boiling, trees growing, rocks crumbling, people aging. That was time, unmeasured, unscheduled, and free of responsibility. There were no minutes, only moments. And even though we now live surrounded by digits and dials and ticking things, that original version of time, the one without numbers, still exists. You can see it in the way shadows stretch across a room, or in how slowly bread molds when you're waiting to see if it does, or in the space between a thought and the words you choose not to say. Humans didn't invent time itself. We just invented ways to talk about it. ways to carve it up, wrap it, sell it, and put it on our walls. We made it into something we could use, like clay or spreadsheets. And in doing so, we made it weird. Because now, time isn't just something we move through. It's something that can be late, or early, or wasted, or well spent. We invented time, in many ways, so we could be mad at it. And there's something a little funny about that. Imagine if we did that with gravity. Ugh, gravity is being so clingy today. Or with sound. That sound is late. But we don't. Because time, unlike gravity or sound, isn't just a force. It's a framework, a calendar, a countdown, a context for everything else we do. We're not just moving through time. We're inside it, all the time, thinking about it, reacting to it, organizing our lives around it, as if it was some kind of cosmic roommate with a very tight schedule. And like any long-term roommate, time occasionally does things that confuse us. It speeds up when we're having fun. It drags when we're stuck in traffic. It stops completely when we're watching a loading bar hit 99%. These aren't just feelings. They're small reminders that our experience of time is deeply subjective, elastic, emotional, tied to our perception and our brain's need to assign meaning to intervals, which leads to one of the most human things we've ever done. We built machines to try and pin time down. Clocks, watches, calendars, apps that vibrate every hour to remind us we exist. We've made time visible, audible, wearable. We've turned it into a number, a line, a circle, a routine. We've synchronized it, digitized it, and beamed it into space. But for all that effort, it still barely works. Our calendar has months with 30 days, 31 days, and once a year, 28 or maybe 29. Our clocks don't match the Earth's rotation perfectly. Our years aren't exactly 365 days. And every so often, we have to shove a leap second into the mix like a surprise guest at a dinner party no one wanted. It's like trying to keep a car on the road by adjusting the wheels every mile with a spoon. But even if our version of time is clunky and approximate, it's still beautiful. Because it reflects our attempt to understand the universe. Not perfectly, but earnestly. Every tick of the clock, every turning page of the calendar, is a tiny act of hope. A belief that the future is coming, and that we'll be there when it arrives. So as we begin this very slow exploration of time, let's not worry about precision. Let's not try to fix it. Let's just sit with it. Let it stretch out like a lazy cat. Let it pass without permission. Let it remind us that sometimes doing nothing is a perfectly valid use of the present. And if you're already starting to feel drowsy, that's completely normal. Time has that effect, especially when it's explained like this. Let your thoughts drift. Let your breathing slow. Let your attention wander as we gently float into the first chapter, where we'll ask, what even is time, really? Time is a concept so familiar we often forget to question what it actually is. We know how to count it, we know how to schedule it, we know how to complain about it. But if someone were to ask you to define time, not what time it is, but what time itself actually means, there's a good chance you'd pause, tilt your head, and maybe answer with something like, it's just time. And that would be fair, because time is one of those ideas that becomes slipperier the harder you try to hold on to it. Let's begin slowly. Time, in the most basic sense, is a way to describe how things change. It's how we know that the cup was full and is now empty, that the candle was tall and is now a stub, that the baby in the photo is now the person asking the question. Without change, there's no need for time. If nothing ever moved, grew, aged, shifted, or unfolded, we'd have no reason to invent a word for before and after. So in that sense, time is just our way of labeling the dance between states. A tree blossoms, the blossom wilts, the leaf falls, the tree sleeps. Time is our word for the unfolding of those moments. It's how we make sense of a world that refuses to stay still. But that's just one version of time, the experiential version. The one we feel in our bones and our clocks and our calendars. Physically, scientifically, time is a bit more peculiar. In physics, time is a dimension, like up and down, left and right, forward and backward. Except you can't turn around in it. Not easily anyway. In the classical model of the universe, time is considered a constant stream in which events occur. It flows from the past, through the present, into the future. Or at least, that's how we perceive it. But the laws of physics don't always treat time so linearly. In fact, many of the fundamental equations work just as well whether time moves forward or backward. This has led some scientists and philosophers to ask a deeply uncomfortable question. Is the passage of time real, or just something our brains are doing? Some have suggested that time might not exist at all, not in the way we think, that it could be an emergent property, something that appears when we observe certain patterns in a certain way, like the illusion of motion in a flipbook. If you look closely, it's just a stack of still images, but flip through them fast enough, and suddenly you see action, intention, continuity. Some say our experience of time might be just like that, a mental slideshow of change, stitched together by memory and perception. And speaking of perception, there's the issue of how personal time is. A minute doesn't always feel like a minute. You've probably noticed that time has moods. Sometimes it sprints, sometimes it crawls. An hour waiting at the dentist is not the same as an hour playing your favorite game or lying under a blanket listening to rain. This isn't just a feeling, it's something neuroscience confirms. Our brains are terrible at measuring time objectively. They speed it up when we're busy, slow it down when we're bored, and stretch it out in moments of panic. In fact, when we're faced with new experiences, our brains record more detail, which can make those moments seem longer in retrospect. That's why your first week in a new city feels like a year, but your 5th year there feels like a blink. And then there are the metaphors we use to talk about time. We say it flies, we say it crawls, we say it slips through our fingers, marches on, stands still. These aren't just poetic quirks, they're clues. Clues that we don't really see time directly. We experience it through other things, through motion, sensation, expectation, memory. We understand time not as a thing in itself, but as the movement of everything else. Which brings us to the most common and relatable way we try to imagine time, as something flowing. One of the oldest and simplest metaphors for time is sand in an hourglass. Grain by grain, the future becomes the present, and then slips into the past. It's visual, it's quiet, it's strangely comforting. It reminds us that time moves slowly, steadily, predictably, even when we're not watching. Another is the river. You may have heard the saying that you can't step into the same river twice. The water changes, the flow continues. In that metaphor, time is not just a stream, it's the environment. We are carried by it. Sometimes we paddle upstream, sometimes we drift. Sometimes we try to cling to a rock and stay still for a while, only to find that even the rock is being worn away by the current. Some thinkers have imagined time as a spiral. Events repeat, but never in quite the same way. Others have imagined it as a wheel, cyclical, like the seasons. And some have described it as a vast frozen block, a 4-dimensional shape in which every moment exists simultaneously, and we just happen to experience one slice at a time, like reading a single page in a very large book. The truth is, time might be all of these things, or none of them. We don't know for sure, but what we do know is that our concept of time is incredibly useful. It allows us to predict, to remember, to plan. It gives shape to experience. Without it, we'd have no past, no future, only now. And while now is a beautiful place to be, it's also kind of confusing when your groceries are still in the car. It's interesting to think about how time allows for narrative. Without time, there's no story. No beginning, middle, or end. Just static facts, unconnected. But add time, and suddenly things happen. A cause leads to an effect. A seed becomes a tree. A question becomes an answer. A problem becomes a punchline. Time turns data into drama, and drama into meaning. Of course, not all cultures have viewed time in the same way. In many indigenous traditions, time is not linear, but cyclical. Life and death, growth and decay, sunrise and sunset, all part of repeating patterns. There is no final destination, just rhythm. This view can be deeply comforting. In a cycle, nothing is ever truly lost. It just returns in another form. In contrast, much of modern Western thought sees time as an arrow, always moving forward, never backward. This has led to ideas like progress, deadlines, expiration dates, and the feeling that we're always running out of something. That if we don't act now, we'll miss our chance. That time is a resource, and once it's spent, it's gone. And while that view has given us great ambition, it also makes us anxious. Because if time is running out, then everything becomes urgent. Even sleep, even relaxation, even the idea of taking a moment to listen to someone explain time slowly over the sound of rain. But here's the gentle truth. No matter how you measure time, it moves at the same pace. 1 second per second. It doesn't care if you're late. It doesn't care if you wasted the afternoon. It just keeps ticking. Not loudly, not cruelly, just consistently, like a soft drum in the background of existence. So whether you see time as a river, a spiral, a schedule, or a mystery, it continues. And tonight, as we let our thoughts settle and wander, we don't need to define it perfectly. We don't need to trap it in a sentence. We can just let it be, let it drift, let it carry us slowly and quietly towards sleep or understanding or simply the next breath. Because the best thing about time, especially now, is that you don't have to do anything with it. You can just let it happen. And while it does, you can rest, you can breathe, you can close your eyes and float like a leaf on a very lazy river. Now that we've sat with the idea of time as humans understand it, abstract, fluid, occasionally ridiculous, we might wonder, how does the universe measure time? Not in hours or days or anything involving daylight saving, but in forces, particles, and strange physics that existed long before we needed clocks. Let's gently drift into that cosmic mystery. If you were to ask the universe what time it is, you wouldn't get an answer. Not because it's being rude, but because the universe doesn't use clocks. It doesn't have a wristwatch. It doesn't glance at the microwave and think, oh, I'm running late for the solar flare. The universe measures time in its own way, on scales too vast, too patient, and too old for anyone to ever be on time or behind schedule. We humans like things divided up. Seconds, minutes, hours, days. We like tidy blocks of time that we can fit into planners and calendars and awkward family reunions. But the universe thinks differently. Its timeline doesn't come with bullet points. It stretches across billions of years like a lazy yawn. And it began, as far as we can tell, with the biggest event that ever happened. The one that kick-started all of this time we're now trying to fall asleep in. That event, of course, is what we call the Big Bang. A name that sounds explosive, but was more like a silent expansion. The birth of space, time, and everything in between, including the occasional tax season, before the Big Bang. If before even means anything at that point, there was no time. No ticking, no past, no sequence. Just a strange, silent, incomprehensible nothing. And then, suddenly, or perhaps not suddenly, since there wasn't any time yet to define it, there was something, a point of infinite density, bursting not into space, but creating space itself. And with that, time began. Not the human kind, with hours and to-do lists, but cosmological time. The kind that counts in billions of years and only glances up every few millennia to check if anything interesting has happened. From that moment on, the universe began expanding, slowly at first, then faster, and then faster still, as if realizing it had double-booked itself and needed to be somewhere else in a hurry. Galaxies formed, stars ignited, planets coalesced, and at some point, on a little blue dot, things like coffee and deadlines were invented. But before we get to all of that, we need to understand one simple idea. Time, for the universe, is about change, just like it is for us, only on a scale that makes our lives look like blinks. The universe keeps track of time by what has changed, by the cooling of gas clouds, the burning of stars, the slow dance of galaxies swirling through space like tipsy dancers at a wedding that never ends. This change follows one of the strangest and most important laws in physics: entropy. Entropy is a word that sounds like a shampoo ingredient, but is really a measure of disorder. It's the idea that the universe tends to move from neatness to messiness, from structure to chaos, from carefully stacked blocks to a pile of scattered Legos in the dark. Entropy is the reason your ice cream melts, not the other way around. It's why a broken egg doesn't reassemble, why your socks get lost but never multiply. It's the universe's one-way street, the law that says things tend to get more complicated, not less. And entropy, as it turns out, is deeply tied to time. In fact, many physicists believe that entropy is what gives time its direction. Without it, time might not have an arrow. It might just sit there, unbothered, going in all directions at once or not at all. But because things tend to get messier, more random, more spread out, we have a sense of past, present, and future. A timeline, carved by the gradual fraying of cosmic order. This is what scientists call the arrow of time. It's not something you can hold or point at, but you feel it all the time. It's why you can remember yesterday but not tomorrow. Why you can eat the soup but not uneat it. It's the reason why spilled milk is such a good metaphor. Because once it's out, and no amount of scooping will put it back in the carton the way it was. This arrow isn't like a clock hand. It's not mechanical. It's natural. It's the result of probability. There are simply more ways for things to be messy than for them to be neat. And so, over time, messiness wins. Always. It's the quiet force behind decay, aging, melting, collapsing, and that drawer in your kitchen you promised to organize 3 years ago. What's even stranger is that if you look at the equations that describe the fundamental forces of physics, gravity, electromagnetism, quantum mechanics, most of them don't actually care which direction time flows. You could run them forward or backward and they'd still work. The math doesn't mind. It's only entropy that insists on a direction. That's why entropy is sometimes described as the universe's historian. It's the one thing keeping track of what already happened and what can't be undone. So, from the universe's perspective, time is less about seconds and more about structure dissolving, about stars burning through their fuel, about the expansion of the cosmos, about complexity unraveling in a very patient, very majestic sort of way. And in that slow unraveling, we find what we call time. It's also why we can't reverse time. Not really. Despite how many movies involve time machines and ticking clocks, and someone shouting, "Go back to 1955, we have no known way to unspool the thread. You can rewind a tape, rewatch a memory, reconstruct a scene, but entropy will always nudge things forward. Even if you manage to arrange all the atoms exactly as they were, you'd still know which way you came from. The milk remembers the pour. And yet, despite its irreversibility, we constantly imagine going backwards. We long for the good old days, as if they were waiting just behind a curtain. We ask, where did the time go? As if it snuck out the back door. We relive memories, revisit photos, reread old messages, all gentle ways of pulling the past into the present, even though we know we can't stay there. It's a very human thing, this wish to reverse the flow, to fix the mistake, unsay the words, unbreak the vase. But the universe isn't built that way. It doesn't keep a backup copy. It's a one-way system, forward, outward, onward. Still, that one-way street has taken us quite far. From an unfathomably dense moment of birth, the universe has expanded into vastness. And time, as defined by that expansion, continues ticking. The cosmic clock doesn't chime or glow. It hums quietly in the background, marking the slow dispersal of energy, the widening of space, the cooling of everything. Cosmological time isn't fast. It's not rushed. It doesn't worry about schedules. It doesn't care about birthdays, deadlines, or anniversaries. It flows at its own pace, light years at a time. And yet, we're a part of it. Every breath you take is a little ripple in the ongoing process, a tiny signature on the universe's long, winding scroll. Even now, while you lie still and listen to words about time, your body is marking it. Cells replacing themselves, neurons firing, atoms jostling and shifting. You are a soft collection of changes, a quiet embodiment of entropy's slow, inevitable stroll. But don't worry, this isn't a bad thing, it just is. The universe moves forward and we move with it. Time isn't our enemy, even if it sometimes feels impatient. It's our companion, our context, our canvas. So when we speak of time, we're really speaking of change, of entropy, of a great cosmic unfolding that began long before we were here and will continue long after. And knowing that, feeling it, gently, is oddly comforting. It means we don't have to rush. We're already moving, carried along by something ancient and vast. Now that we've floated through the grand timeline of the universe, the Big Bang, the cooling stars, the irreversible arrow, we can slowly zoom in, Because while the universe tells time through stars and galaxies, Earth tells it a little differently, with tides, with seasons, with a sun that rises and falls just for us. So let's drift down, gently, to the place we call home, and see how our tiny blue planet keeps time. If you were designing a planet from scratch and wanted it to have a decent sense of time, Earth wouldn't be the worst model to copy. It's a tidy little system, spinning, orbiting, tilting, just enough to keep things interesting. But despite how intuitive the sunrise feels, or how naturally the seasons seem to flow, Earth's idea of time is, at its core, a cosmic accident. An accident that just so happens to govern nearly everything we call a schedule. Let's start with the basics. Earth spins, constantly, patiently, like a lazy top that never winds down. It does this once every 24 hours, give or take a few milliseconds. And that simple, ceaseless rotation gives us something incredibly familiar. The day. A day, as we think of it, isn't a fixed chunk of time built into the universe. It's the result of a planet slowly turning in space, exposing itself to light, and then shadow, like a rotisserie chicken in front of a sun lamp. The sun doesn't rise. The Earth turns. You're just sitting on the side that happens to face it right now. And when your bit of Earth rotates away, night falls. Not because the sun moved, but because your seat swiveled. This rotation is so steady we built our entire rhythm around it. Workdays, rest days, breakfasts, sunsets. Our bodies even follow its pattern. The circadian rhythm, a 24-hour internal cycle tuned to light and darkness, sleep and wakefulness. It governs hormones, mood, metabolism, and the mysterious power of the snooze button. But while Earth's rotation gives us days, it also creates problems. For one, it's not perfectly stable. The Earth is slowing down. Very, very slowly. Due to gravitational interactions, especially with the Moon, our planet's rotation is losing a few milliseconds every century. At this rate, you probably won't notice unless you're planning to live for a few million years. But it's happening. And every now and then, just to keep the clocks honest, we add a leap second. The temporal equivalent of saying, wait, hang on, let me catch up. So if the day is a product of spinning, what about the year? That's Earth doing another trick, orbiting. Our little blue marble doesn't just rotate, it also circles the sun. One full trip around the sun takes approximately 365.25 days. The 0.25 part is why we have leap years. Every 4 years we throw in an extra day like a cosmic bonus round just to stay synchronized with reality. Without it, our calendar would slowly drift out of alignment, and eventually we'd be celebrating New Year's in the middle of autumn, wearing party hats in a pile of leaves. This orbit is what gives us our annual cycle. It defines what we call a year, a journey not through space, but through change. Plants grow, die, and return. Animals migrate, hibernate, and re-emerge. Human beings throw on sweaters, take them off again, and then do it all over, year after year, pretending to be surprised by the weather. But there's more. Earth doesn't just spin and orbit, it also wobbles. Not in an unstable way, more like a tilted top leaning ever so slightly. This tilt, about 23.5 degrees, is what gives us seasons. Without it, the weather would be much more uniform, and the fashion industry would be a lot less complicated. Because of this axial tilt, different parts of the Earth receive different amounts of sunlight throughout the year. When the North Pole is tilted toward the sun, the Northern Hemisphere experiences summer, longer days, warmer temperatures, and the annual debate about whether air conditioning is a need or a luxury. When the South Pole takes its turn leaning in, the Southern Hemisphere gets its summer, and the North settles into winter. Cozy socks, darker afternoons, and a slightly heightened awareness of how cold your kitchen floor is. This dance of tilt and orbit means that even though our clocks and calendars feel neat and regular, they're actually built on top of a complex ballet of gravitational forces, axial inclinations, and orbital eccentricities. Every second we count is really just a way of describing how our planet is behaving in space, spinning, circling, tilting, wobbling, and occasionally shrugging off meteorites. What we call natural time, sunrise, sunset, months, seasons, is just Earth's interpretation of the cosmic rhythms. And it's worth noting that none of it is perfectly clean. The year isn't exactly 365 days. The day isn't exactly 24 hours. The seasons don't begin precisely on the same date every time. Our planet does its best, but it's not a clockmaker. It's more like a jazz musician, improvising within patterns, mostly consistent, but always with a little wiggle room. Even the moon gets involved. Its orbit affects tides, which in turn affect ecosystems, and even the internal clocks of certain animals. Corals spawn on precise lunar cycles. Crabs migrate with the tides. Some fish lay eggs according to the moon's phases. There's a strange poetry to it. Time measured not in numbers, but in rhythms, pulses, recurring whispers in the natural world that say, now it's time. And yet, as elegant as this all is, it's not especially human-friendly. Our ancestors noticed these patterns, the arc of the sun, the phases of the moon, the swell of the tide, and tried to translate them into something usable, something you could write down, predict, organize around. And that's where things started getting messy. But before we step into humanity's ambitious attempts to tame time, it's worth appreciating just how weird and elegant Earth's natural clockwork is. Imagine standing on the surface of the planet, looking up at the sky. The stars drift slowly. The sun arcs from one horizon to another. Shadows stretch and shrink. Tides rise and fall. Birds migrate overhead. Every single one of these changes is a kind of clock, a marker of movement, a signal of progression. Long before we had machines, we had these natural signals. Shepherds watched the length of shadows. Sailors studied the stars. Farmers tuned their planting to the sun and the frost. People told time by listening to the earth breathe. It wasn't exact, but it worked, at least most of the time. Enough to grow food, enough to find your way, enough to know when to gather, when to rest, when to expect the rains. But of course, people being people, we wanted more precision. We wanted numbers. We wanted repeatability. We wanted to look at a wooden stick and say, yes, it is exactly 3:42 in the afternoon. And that's where things started to get funny, because when humans try to turn a planet's chaotic rhythms into something they can wear on their wrist, compromises must be made. Rounding errors, leap days, decimal confusion, entire empires arguing about whether the year should start in March or January. And thus began our long, strange attempt to box up time and carry it around like a pet, to measure it, divide it, conquer it, to make Earth's messy, majestic cycles fit neatly inside a circle with numbers on it. But before we dive into humanity's slightly unhinged calendar experiments, let's take one more moment to appreciate where we are. You, right now, are lying on a spinning, orbiting, wobbling rock. You're hurtling through space at thousands of kilometers per hour, and yet you feel still. You mark your days by the rising and setting of a star you don't even feel moving. The passage of time as you know it is a side effect of that grand motion, that soft, perpetual turning. And though we like to pretend we're in control of time, we are, in the end, still passengers. Just well-informed passengers with appointment reminders and daylight-saving confusion. Now, let's watch how people tried to wrestle time into submission, with sundials that didn't work on cloudy days, with calendars that forgot how long a year was, and with the deeply human urge to make chaos behave using math. At some point, thousands of years ago, a human being looked up at the sky, saw the sun hanging there like a slow-burning coin, and thought, I need to know when lunch is. Thus began our long and awkward relationship with timekeeping. Humans didn't invent time itself. We've covered that. The universe already had a perfectly decent system in place involving planetary motion, axial tilt, and a cosmic sense of rhythm. What humans invented was the idea of keeping time, of tracking it, of turning it into something measurable, portable, and, ideally, more useful than simply guessing when to go inside. And naturally, we started by looking at what we could see. The sky. The moon in particular was a favorite. It was obvious, it was big, and it kept showing up in phases. Waxing, waning, disappearing, reappearing. Like a moody spotlight with a monthly performance schedule. Early people noticed this pattern and decided, with admirable logic, that maybe months should be based on the moon. And so they were. Lunar calendars were born. But the moon, for all its glow and drama, is not an especially punctual employee. A full lunar cycle, from new moon to full and back again, takes about 29.5 days, which is just annoying, because that means a calendar of 12 lunar months only gets you about 354 days. That's 11 days short of the solar year, the time it takes Earth to orbit the Sun, and 11 days may not seem like much. But after just a few years, your months start drifting noticeably out of sync with the seasons. Suddenly, spring festivals are happening in the snow, and harvest celebrations arrive before anything has ripened. Some cultures didn't mind. Others added leap months. A whole extra moon's worth of time tossed in occasionally like a bonus round. This patchwork system kept things vaguely aligned, but it wasn't elegant. It was like trying to hem a shirt using bubblegum and optimism. Then there were solar calendars. These were based not on the moon, but on the sun's position in the sky. Ancient Egyptians, for instance, watched the annual flooding of the Nile, which occurred reliably after the heliacal rising of the star Sirius. This celestial event became a kind of seasonal marker. They built calendars with 365 days, split into 12 months of 30 days each, plus 5 festival days at the end. No leap year, no decimals, just vibes and some decent geometry. The problem? 365 days is still slightly too short. The real solar year is closer to 365.2422 days, which doesn't sound like a big deal. But just wait a few centuries, and everything's shifted again. Over time, even a tiny error compounds, and your new year starts landing somewhere in midsummer. Still, the Egyptian system was impressively close, especially considering they didn't have telescopes or spreadsheets. Just good observation and a solid tan. Then came the Babylonians, who brought with them one of humanity's greatest contributions to timekeeping, the week. Specifically, a 7-day week. Why 7? Well, partly because of the 7 visible celestial bodies in the sky at the time, the sun, the moon, and the 5 visible planets. And partly because the number 7 just felt kind of magical. It shows up a lot in ancient systems. 7 heavens, 7 gates, 7 sages. They liked 7, and honestly, we still do. It's a manageable number of days between minor existential crises. This idea caught on, and many civilizations adopted or adapted it. The week became a tool for organizing life into regular intervals, a repeating loop of duties, rituals, markets, and rest. It was the earliest version of same time next week, and eventually, it's only Tuesday. Meanwhile, as cultures across the world wrestled with celestial timekeeping, they also began developing physical devices to help track it on a smaller scale. The Egyptians, again ahead of the curve, used obelisks, tall stone pillars whose shadows moved predictably throughout the day. These functioned like giant sundials. If the shadow was here, it was morning. If it was there, it was afternoon. If you couldn't see the shadow, it was probably cloudy, and time didn't count. Other methods emerged. In India and China, people used water clocks. These were simple containers with tiny holes that allowed water to drip from one vessel into another. By measuring how long it took to fill up, you could estimate time, assuming no one bumped the table and the water flowed perfectly, and you didn't fall asleep watching it. Spoiler, people often did. Then there were candle clocks. Candles marked with lines to show how much time had passed as they burned down. Or incense clocks, which worked the same way, but smelled better. These devices were practical, creative, and wildly imprecise. But they represented the same desire: to slice time into pieces, carry it with us, use it to structure the day. The issue, though, was that all these early systems were local. They worked in specific places, with specific rules tied to specific celestial observations. A lunar calendar in one part of the world might not match the moon phases somewhere else. A sundial in Egypt didn't work so well in Norway, unless you liked measuring months of continuous darkness. And yet, despite the confusion, the overlap, the different systems with different start dates and different numbers of months and even different years, people kept going. We refined. We invented better tools. We tried harder. Because the idea of organizing life around predictable time was just too good to abandon. But it wasn't always pretty. Take, for example, the Roman calendar. It began with 10 months. 10. That's it. March to December. Which explains why December, from the Latin decem, meaning 10, is our 12th month. The Romans just added January and February later, like patching holes in a calendar-shaped boat. They also had weird month lengths, 29 days here, 31 there, 28 sometimes, 27 if you blinked. It was chaos, managed mostly by priests who could arbitrarily declare when a month should be longer or shorter, often for political reasons. Imagine if election years just had extra days for convenience. Eventually, Julius Caesar had enough. In 46 BCE, he introduced the Julian calendar, a reform based on a 365.25-day year, with a leap year every 4 years. This was a huge improvement. Months got fixed lengths. The year became more stable. The calendar finally began to match the seasons again. The only problem was, it was still slightly off, by about 11 minutes per year, which sounds harmless until you realize that after a few centuries, spring starts arriving in February again. Fast forward to the 16th century, and the Catholic Church steps in. Pope Gregory XIII introduces the Gregorian calendar, the one we use today. It adjusts the leap year rules. A leap year every 4 years, unless the year is divisible by 100, unless it's also divisible by 400. Yes, it's a math puzzle, and no, you don't need to memorize it to fall asleep. But it fixed the problem, mostly. This new system was more accurate. It synced better with the solar year, but it wasn't adopted everywhere at once. Some countries switched quickly. Others, suspicious or just stubborn, took centuries. In fact, some Orthodox churches still use older calendars today, meaning that even in the 21st century, we still can't all agree on what year it is. But back in the ancient world, long before Gregorian logic and Julian tweaks, time was local, seasonal, and often deeply spiritual. It wasn't just a measurement, it was a worldview. Calendars were tied to harvests, festivals, omens, and rituals. Time wasn't something to master, but something to respect. A cycle, a rhythm, a pattern seen in the stars and the soil. And yet, humans being humans, we kept trying to fix it, to measure it better, to make it portable, predictable, permanent. We took a planet's spin, a moon's wobble, a sun's arc, and tried to turn them into schedules, rules, and eventually wristwatches. And somehow, through a swirling mess of mistakes, politics, astronomy, guesswork, and divine intervention, we got there. Mostly. Still, for all the effort, these early systems were, let's say, optimistic, full of errors, approximations, and improvisations. And they paved the way for an entire genre of devices designed to make us feel like we were finally in control of time. Next, we'll meet some of those inventions. From sundials that lied whenever clouds rolled in, to water clocks that dribbled away your afternoon. Each one an earnest attempt to trap time in a container, and each one only slightly successful. Imagine you're an ancient person. You don't have a phone, a calendar, or even a post-it note, but you do have things to do. Fields to tend, rituals to perform, questionable soups to stir. And at some point, it occurs to you that it would be really helpful to know what time it is, not just whether it's light or dark, but something more specific, like mid-morning-ish or almost lunch. So naturally you look at the sun, and thus the sundial is born. Sundials were among humanity's first real attempts to measure time in real time. The concept is simple. Stick something upright in the ground, a stone, a stick, maybe your friend who's good at standing still, and observe how the shadow moves as the sun arcs across the sky. With a little bit of marking, some trial and error, and probably a few arguments, you get yourself a tool that can tell you roughly what time it is based on where the shadow falls. It sounds elegant, and in the right conditions, it kind of is. Sundials don't need batteries. They're weather resistant, mostly, and they're impressively ancient. The earliest known sundials date back to around 1500 BCE in Egypt and Mesopotamia. That's older than most written languages, older than currency, older, even, than the phrase "I'm running late." But sundials have a tiny problem. Well, a few actually. The first is that they only work when there's sun. Cloudy day? No time for you. Stormy sky? You exist in a timeless void. Nighttime? Forget it. According to a sundial, midnight is indistinguishable from being inside a cave with your eyes closed. The second issue is that sundials are local. They only work in the place they're built for. A sundial calibrated for Athens won't tell the right time in Cairo. Latitude, angle, and geography all affect where the shadow lands. If you try to take your sundial on vacation, prepare to be confused. And then there's the awkward truth that time itself isn't consistent across the day. Because of Earth's elliptical orbit and axial tilt, the sun doesn't move at a perfectly uniform speed across the sky. This means that sundial time, what's called apparent solar time, can differ from clock time by as much as 15 minutes, depending on the time of year. Ancient people didn't worry too much about that. But imagine trying to schedule a haircut if noon meant sometime within a 30-minute window, give or take. Not great for punctuality. Still, sundials were better than nothing. And they were beautiful. Some were etched in marble, others carved into the walls of temples. Many came with poetic inscriptions. One Greek sundial read, "I count only the sunny hours," which, if you think about it, is either a lovely metaphor for optimism or an excellent excuse for forgetting your appointments. But humans, being endlessly ambitious, wanted more. We wanted to measure time when the sun wasn't cooperating. So we got creative. Enter the water clock. Water clocks, or clepsydras, from the Greek for water thief, were another ancient invention aimed at tracking time without relying on the heavens. The basic idea: take a container, fill it with water, poke a small hole in the bottom, and let the water drain out at a predictable rate. If you mark the container with lines, you can tell how much time has passed by how low the water has dropped. Simple, right? Yes, and also kind of a disaster. For one, water doesn't always behave predictably. Temperature, pressure, impurities, and the size of the hole all affect how fast it drips. If it's hot, the water flows faster. If the container isn't perfectly level, you get uneven flow. If someone sneezes near it, you might lose 3 minutes. Also, water evaporates, slowly, but enough to mess with long-term accuracy. And then there's the issue of refilling. Unless someone was paying close attention, you'd eventually find yourself with an empty vessel and no idea how long it had been that way. Time, quite literally, slipped away. Despite all that, water clocks were popular for centuries. They were used in ancient Egypt, Greece, China, India, and the Islamic world. Some were quite sophisticated, equipped with gears, floats, and valves to control the flow, and even make adjustments for seasonal changes. In China, engineers built enormous water-powered astronomical clocks that doubled as timekeeping machines and scientific instruments. They didn't just leak time, they turned it into a show. But even the best water clocks had limitations. Like sundials, they worked best in calm, controlled environments, and they were rarely portable. You couldn't just strap one to your belt and go for a walk. They were more like indoor furniture, elaborate, finicky, slightly damp furniture. So people tried other things: fire clocks, sand timers, incense clocks that burned at a consistent rate and released a new scent every hour, which was lovely until you forgot which smell meant pay your taxes. Each of these inventions had charm and varying degrees of success, but all of them faced the same core issue. They were based on processes that, while roughly regular, were not consistent enough to keep precise time over long periods. And there's a philosophical twist here, one that feels oddly profound when you're trying to fall asleep. All of these early clocks, sundials, water clocks, candles, incense, shared a common trait. They could only measure the present moment by sacrificing something. You couldn't tell time without losing something in the process. A shadow moved, water vanished, wax melted, sand slipped away. Time was always measured by change, by decay, by disappearance, which, in a way, feels poetic. These were clocks that mimicked life itself. You couldn't pause them, you couldn't rewind them. You could only watch as something precious drained away, grain by grain, drop by drop. And because these clocks were so dependent on physical conditions, they often lied. Not on purpose, of course. Clocks don't have malice, but they were unreliable narrators. The sundial told you noon had come, but only if the sun agreed. The water clock claimed an hour had passed, but only if it hadn't been tampered with, or tilted, or topped up. These devices were honest in design, but dishonest in practice. Time became not a fact, but an estimate, an educated guess, wrapped in bronze or stone, swaying ever so slightly in the breeze. And yet, these clocks shaped civilizations. They were used to regulate speeches in Athenian courts, to time religious rituals, to coordinate city gates and temple bells. They gave people a shared sense of rhythm, however fuzzy that rhythm might have been. They also paved the way for something more precise: Because as useful as shadows and drips and smells were, there came a point where kind of close wasn't close enough, especially when people started relying on time not just for ritual, but for work, travel, trade, and science. The world was getting faster, more crowded, more scheduled. And when things get crowded, you want to know not just whether it's morning or evening, but whether it's 8:03 or 8:07. You need consistency. You need control. You need something that doesn't depend on the weather or evaporation or shadows. You need gears. And so, the world shifted. From natural processes to mechanical precision. From leaky bowls and tilted sundials to ticking gears and ringing bells. The age of approximate time was coming to a close. Still, there's something charming about these early attempts. They remind us that timekeeping wasn't always about numbers or stress. It was a process of watching, listening, feeling the rhythms of the world. It was tied to nature, to ritual, to change. It was imprecise, yes, but it was also patient. And in a way, these ancient timekeepers weren't lying. They were just imperfect storytellers, trying to describe something as slippery and strange as time using the tools they had. Shadows, water, wax, incense, each one a soft whisper saying, "Time is passing, something is changing. Notice." As we keep drifting away, we'll watch what happens when humanity trades in those soft whispers for something louder, something made of wheels and weights and ticking hands. When guessing ends and precision begins, the era of mechanical clocks is about to arrive, and time will never be the same. Timekeeping, up to this point, had mostly been a polite suggestion. A whisper from the sun, a trickle of water, a shadow gliding lazily across a temple wall. It worked well enough for planting crops, organizing festivals, or knowing when the goats were starting to look hungry. But as societies grew more complex, trade expanded, cities became denser, and human activity more interconnected, that quiet flexibility began to fray. People needed to know not just around when, but exactly when. And so, the age of soft guesses gave way to the era of hard clicks. The mechanical clock did not arrive all at once, nor did it appear from thin air. It was the product of centuries of experimentation. Gears carved by hand, weights hung with careful calculation, and ideas borrowed from earlier technologies like the escapement mechanisms used in ancient Greek water clocks, or even in cathedral automata. But by the 13th and 14th centuries in Europe, something began to change. Tower clocks appeared in town squares, tolling the hours for everyone within earshot. And with them came something the world had never truly known before. Shared, mechanical time. Imagine the first time a medieval town heard a bell ring out to announce the hour. Loud, decisive, unapologetic. It didn't matter if the sun was out or if clouds hung low and sulking. The clock had spoken. It was noon because the gears said so. And if the bell was off by a few minutes, well, it was still right enough that people began to trust it more than the sky. These early mechanical clocks were grand, unwieldy things. Most were powered by falling weights connected to a system of gears. The crucial invention that made them possible was the escapement, a mechanism that regulated the release of energy, allowing the gears to turn at a steady rate instead of spinning wildly. This invention transformed the idea of a clock from something reactive, like a sundial, to something proactive. Now, time could be divided by a machine, no shadows required. The escapement made the tick-tock rhythm possible. Before this, there had been no ticking. Time had been a flow, a drift, a quiet movement across the sky or through a bowl. But now, with every tick, a little tooth on a gear clicked into place. With every tock, a weight shifted slightly downward. Time, for the first time in human history, became segmented, predictable, externalized. A sound that said, with conviction, "This is now. This is now. This is now." And it was loud. Tower clocks weren't built to be subtle. They had to be heard across the marketplace, through narrow alleyways, over the din of horses and merchants. Some towns even employed clock keepers, whose job it was to wind the mechanisms and ensure the bells rang on time. A bad clock keeper might throw off the entire rhythm of the city. Marriages delayed, prayers missed, beer brewed too long or too short. In a world growing steadily more organized, time was becoming an authority figure. With these tower clocks came a cultural shift. Time was no longer tied to nature or personal experience. It wasn't about how long the light lasted or how high the sun stood in the sky. It was about what the clock said. Hours became appointments. Work days acquired structure. Markets opened and closed at predictable times. People began synchronizing, not with the world around them, but with machines. It wasn't long before the desire for portable timekeeping grew stronger. After all, not everyone could live within earshot of a bell tower, and so began the miniaturization of mechanical time. By the 15th and 16th centuries, personal clocks and early watches were being made. First as ornate, unreliable status symbols worn by nobles, and eventually as more practical devices for those who could afford them. These early portable clocks didn't have minute hands. In fact, some didn't even have hands at all. They rang bells to signal the hour, or displayed rotating discs with painted scenes that shifted with the time. But they were enough to start divorcing people from the need to observe the sky, enough to start believing that time was something that could be carried around, owned, managed, even hoarded. A watch, in this context, was more than a tool. It was a declaration. I no longer need to rely on nature, it said. I can summon time from my pocket. Of course, the accuracy of these early devices left much to be desired. Temperature affected the metal. Springs coiled inconsistently. Balance wheels wobbled. A clock might gain or lose 15 minutes a day, but even so, the mechanical principle had been established. Time was now something people tried to control, not just observe. And what a shift that was. In a sundial world, time had been flexible. It bent with the seasons, with the light, with the clouds. In a mechanical world, time became rigid, structured, sliced into clean intervals. The idea of being late suddenly had meaning, because now there was a shared standard against which lateness could be measured. Clocks brought discipline, but also anxiety. Before mechanical clocks, no one showed up 10 minutes behind. You just showed up when you got there. It's easy to overlook how recent this change is. For the vast majority of human existence, time was relational. Now it was absolute, or at least pretended to be. It ticked onward whether you were watching or not, whether you were resting or rushing, whether you wanted it to or not. And while these machines started in churches and town squares, they soon spread into homes, schools, factories. By the time of the Industrial Revolution, the mechanical clock was no longer a curiosity, it was an enforcer. Factory bells dictated shift changes, school bells signaled class periods, trains ran on timetables, and timetables had no patience for poetic delays. Time, once a drifting companion, became a drill sergeant. Still, there's a quiet magic in those old gears. The soft clicking, the rhythmic pulsing, the patience of springs and pendulums. In some ways, mechanical clocks were the most honest timekeepers we'd ever built. Not because they were perfect, but because they kept trying. Tick by tick, day by day. A tiny metal heartbeat reminding you that the world was turning. And even now, when we wear digital watches and consult phones that sync to satellites, we still admire the beauty of a well-made clock, the craftsmanship, the dedication, the audacity of thinking we could tame something as fluid as time with brass and balance wheels. In a strange way, the birth of mechanical timekeeping changed our relationship with time forever. It became something to serve, something to obey, but also something to improve, refine, and protect. A shared structure, a metronome for civilization. Of course, if you're listening to this to fall asleep, none of that matters much now. You're not working in a factory. You're not rushing for a train. You're just here, maybe listening to the quiet, maybe drifting a bit, maybe wondering how long you've been lying still. And that's okay, because time doesn't need to be watched. It's doing what it always does, continuing. Before the mechanical era, no one had a minute hand. But eventually, even the hour wasn't precise enough. We wanted more granularity, more control, more numbers. So we took the hour and we broke it, again and again, until we arrived at minutes, then seconds, and eventually, something close to madness. For most of human history, the hour was good enough. After all, an hour is a comfortable unit of time. It's long enough to do something, short enough not to panic. In a world without meetings, trains, or microwave timers, you rarely needed more precision than that. But humans, driven by equal parts curiosity and a tendency to overcomplicate everything, eventually decided, let's divide the hour into smaller pieces so we can be late in more detail. Thus were born the minute and the second, two of the most recognizable and arguably most arbitrary units in the modern world. Let's start with the number 60. Why is the hour divided into 60 minutes and the minute into 60 seconds? It sounds neat enough, but it's not based on the human body or natural cycles or anything as intuitive as the sun or the moon. Instead, it's the mathematical ghost of a long-dead civilization, the Babylonians. The Babylonians were big fans of the sexagesimal system, that is, base 60. Unlike our modern base 10, which is based on having 10 fingers and therefore is biologically convenient, base 60 has no such anatomical justification. But it does have one thing going for it. It's extremely divisible. 60 can be evenly divided by 2, 3, 4, 5, and 6, among others. That makes it wonderfully convenient for carving up circles, measuring angles, and, eventually, breaking up hours. Babylonian astronomers were already using base 60 over 3,000 years ago to track celestial movement. They divided circles into 360 degrees, another Babylonian hand-me-down, partly because 360 is close to the number of days in a year, and partly because it's divisible by an impressively large number of integers. When Greek mathematicians inherited Babylonian astronomy, they also inherited their math. In time, this led to the hour, itself a division of the day, being split into 60 equal parts, each one a minute. And then, each of those minutes was divided again into 60 smaller parts, seconds. The word minute actually comes from the Latin pars minuta prima, meaning first small part. The second comes from pars minuta secunda, second small part. Yes, seconds are literally the second small part of an hour, and minutes are just the first. In that sense, the names are less poetic and more like labels on a filing cabinet. But practical or not, this system stuck. It was strange, inherited, and deeply rooted in ancient number theory, and no one could come up with anything better, so we kept it. Even today, in a world where everything from computers to spacecraft runs on base 2, base 10, or floating point logic, we still tell time in 60s. We still carve our days into these weird Babylonian crumbs. Of course, no one really needed minutes and seconds in the ancient world. If you showed up somewhere in the morning, you were on time. But as mechanical clocks improved, they started gaining minute hands. Eventually, second hands. Suddenly, it mattered whether you arrived at 9:02 or 9:07. Precision seeped in like water through a leaky roof, quietly at first, then relentlessly. And that's when naps got ruined. Think about it. When time is just morning and evening, you nap when you're tired. You wake up when you're done. Life moves in rhythms, not numbers. But when time is measured in minutes, naps become quantifiable, schedulable, trimmable. You're no longer dozing off. You're resting for 23 minutes before the next thing. And once time is that finely chopped, everything becomes measurable. And, by extension, judgeable. You're not just around lunch. You're 15 minutes late to lunch. You're not almost ready. You're 6 minutes behind schedule. You don't wake up naturally. Your alarm screeches at exactly 7 a.m. because 6:59 would be too early and 7:01 would feel like failure. There's something almost tragic in that. Minutes and seconds made life more precise, yes, but they also made it more rigid, less forgiving, less gentle. The moment you break an hour into 60 tiny pieces, you invite the possibility of measuring every one of them. And with measurement comes expectation. That said, there's no denying the usefulness. Without minutes and seconds, you can't coordinate a train schedule, or run a scientific experiment, or time a souffle. And let's be honest, some things are better with a stopwatch. The Olympic Games, for example, would be much harder to narrate if winners were declared based on vague approximations. And it looks like he finished the race, sometime shortly after the other guy, possibly before lunch. The invention of minutes and seconds also opened the door for innovations in navigation and astronomy. With precise timekeeping, sailors could calculate longitude, a breakthrough that saved countless lives and made global trade more reliable. Scientists could observe celestial events with greater detail. Astronomers like Galileo could measure the oscillations of pendulums and get curious about falling objects. Seconds, tiny as they are, made room for scientific progress, but not without consequences. The moment you introduce detailed measurement, you introduce pressure. Hurry up. You're late. We're behind. All things that are impossible to say when your only units of time are dawn and when the goats come back. Time shrank. And as it did, our perception of it changed. Hours became too large. We stopped seeing a day as something to experience and started seeing it as something to schedule. One of the more peculiar side effects of this change was how we began to see ourselves. People no longer just lived in time, they performed in it. A minute wasn't just a slice of an hour, it became a deadline, a measurement of productivity, a symbol of urgency. We learned to count the seconds, to shave off time, to squeeze more into less. We learned to chase time, and inevitably, to feel like we were losing it. It's no coincidence that the rise of modern stress coincided with the rise of modern timekeeping. As clocks improved, people were expected to match their pace, and as the pace increased, so did the sense of not keeping up. Time wasn't just something you observed anymore. It became something you competed with, and yet we still use these divisions every day, often without thinking about their strange origins. You glance at the clock and see 7:43. That number has traveled through centuries of mathematical decisions, cultural inheritances, and philosophical dilemmas just to tell you that you're almost late for coffee. And maybe that's worth pausing for, not to change it necessarily, but to recognize how odd it is that we divide our day into 86,400 seconds, each one ticking away with a kind of soft tyranny. So the next time you look at a digital display glowing 12 seconds, know that you're looking at Babylonian math, filtered through medieval gears, filtered again through modern anxiety. It's not a judgment, it's just a gentle reminder. That time, for all its apparent authority, is a human story, a set of agreed-upon divisions carved into the endless drift of existence. And if you ever feel behind, just remember, time was always meant to be approximate. We only turned it into a race because we started measuring it too closely. Of course, all this precision only created new problems. Once everyone was carrying synchronized clocks, a new kind of confusion emerged, a chaos of coordination, especially across distances. Because as it turns out, when it's 3 hours here, it's not necessarily 3 hours somewhere else, not even close. And that realization brought us face to face with one of humanity's boldest and most headache-inducing inventions, the time zone. For most of human history, time was local. It was solar. It was personal. When the sun hit a certain angle over your village, you called it noon. A few miles east, it might be a few minutes earlier. A few miles west, a bit later, and that was fine. Because you weren't coordinating Zoom meetings or international flights. You were harvesting barley, walking to the market, maybe napping under a tree if the goats weren't looking. But then the trains came. Trains didn't care about your tree naps. Trains had schedules. They had printed timetables, passenger stops, cargo connections. A train that left a station at 3:15 p.m. had to mean exactly 3:15 p.m. Not a little past afternoon depending on which hill you live near. The industrial age had arrived and it demanded punctuality. In the early 19th century, as railroads began crisscrossing continents like steel stitches, time became a logistical nightmare. Each town still operated on its own local solar time based on the position of the sun. That meant when it was noon in one city, it could be 12:12 in the next town over. Not a big deal if you're walking. A massive deal if you're operating a 40-ton locomotive hurtling down a track that may or may not be shared with another train. Train companies tried to make sense of it. Some set all their clocks to a central hub, usually a major city like London or Paris. Conductors carried watches that disagreed with the towns they rolled through. Station clocks were sometimes deliberately wrong to match the rail schedule. It was chaos with a timetable. And eventually, someone said, "We need a system. Enter Greenwich Mean Time, or GMT." In 1884, an international conference convened in Washington, D.C., with the goal of standardizing time around the world. A bold task, considering the world hadn't agreed on much at that point, including how to spell color. But they managed. The conference chose the Royal Observatory in Greenwich, England, as the prime meridian. the 0 point of longitude. From there, the globe was divided into 24 time zones, each theoretically 1 hour apart, spaced 15 degrees of longitude apart. This idea was, in theory, beautiful. A global clock, a universal rhythm, time that ticked smoothly around the planet like a polite baton passed between nations. In practice, well, it's Earth, so things got messy. For one thing, not every country agreed immediately. France held out, preferring Paris Mean Time for a while. Local resistance was common. After all, you're not just changing the time, you're changing people's relationship with the sun. In some places, noon suddenly no longer meant the sun was overhead. People were confused, farmers grumbled, clocks were reset with suspicion, and even once time zones were adopted, they weren't always neat. Political borders, geography, and national pride got involved. Some countries stretched their time zones for convenience. Others refused to split their country across zones, even when logic begged them to. Take China, for example. Geographically, it spans 5 time zones, but the entire country runs on a single time, Beijing time. That means in Western China, the sun might rise at 10 a.m. local time. Lunch might technically be served at what feels like breakfast. It's like living your whole life slightly jet-lagged, but out of patriotism. Then there are the oddballs, the time zones that refuse to follow the rules, like India, which decided it didn't want to be exactly 5 or 6 hours ahead of GMT. No, it went with 5.5. Just to be interesting. And it gets better. Nepal. UTC Play 5.45. Yes, a 45-minute offset. Because why not? Somewhere out there, a Nepali clock is ticking away smugly, knowing it's living 15 minutes in the future of India and 15 minutes behind wherever makes the most sense. Other places went with full-hour offsets but in odd directions. Newfoundland, for instance, uses UTC 3:30. Some parts of Australia have offsets like UTC plus 9:30 or UTC plus 10:30. It's a wonder anyone can schedule a phone call with confidence. And the prize for time zone boldness might go to the Chatham Islands in New Zealand, which decided on UTC plus 12:45, just in case anyone thought the system was too orderly. Then there's the matter of who decides what time it is. In some places, borders dictate the zone. In others, it's local choice. For example, in the United States, there are several counties that observe different time zones than the rest of their state. One town might be on Central Time while the gas station just across the street is on Mountain Time. Arizona refuses to observe daylight saving time. More on that in a moment. But the Navajo Nation within Arizona does observe it, which means you can be in Arizona, drive into the Navajo Nation, and change your clocks, only to drive into the Hopi Reservation, inside the Navajo Nation, where daylight saving time isn't observed. That's 3 time zones in one desert without crossing a national border. Good luck with your wristwatch. And of course, time zones have effects beyond just scheduling headaches. They create cultural quirks. In Spain, for instance, the time zone is artificially shifted due to a World War II decision to align with Nazi Germany. As a result, lunch is famously late, often around 2 or 3 p.m., and dinner can stretch into the night. It's not just a culinary choice. It's baked into the time math. Some lucky people even get extra weekend. If you live near a time zone border and your work ends at 5 p.m., but your favorite bar is across the line where it's still 4 p.m., congratulations. You just won 60 bonus minutes of Friday. That's time zone hacking at its finest. In essence, time zones are a map painted with clocks, often imprecisely, occasionally politically, and rarely with the straight lines promised by their original architects. They're a compromise between the logic of the Earth's rotation and the chaos of human borders. But even with all their quirks and confusion, time zones serve an important purpose. They allow us to coordinate, to communicate, to travel, and to pretend, however briefly, that we all agree what time it is. And if you've ever scheduled a Zoom call at 3 p.m. Pacific and accidentally showed up an hour late because you were thinking in Eastern, you felt their wrath. Time zones giveth, and time zones taketh away. Still, in the grand scheme of time's long and wobbly history, time zones are a relatively recent invention, less than 2 centuries old. They've already morphed and sprawled and twisted themselves into strange shapes, and in some places, quietly continue to cause headaches. But just when the world had started adjusting to this patchwork of hours, someone had another bright idea. What if, hear us out, We change the clocks twice a year. What if we invented a seasonal time twist that would throw off everyone's schedule, confuse digital systems, and divide nations? Also, we could pretend we were saving sunlight. Yes, it's time to enter the bewildering tradition of moving time forward, and then back again. There are few moments in the year that feel quite as quietly absurd as waking up, looking at the clock, and realizing it has betrayed you. You went to bed at a reasonable time, you followed your routine, you even remembered to brush your teeth, and yet somehow you've lost an hour. Not to forgetfulness or distraction, but because someone, somewhere, decided that the clocks needed adjusting. Again, welcome to daylight saving time, the biannual tradition of pretending we can manipulate the sun by fiddling with our wristwatches. Let's start with the basics. Daylight saving time, or DST, is the practice of setting clocks forward by 1 hour in the spring and back by 1 hour in the fall. In theory, this gives us more daylight during the evening hours of summer. In practice, it gives us more confusion, sleep disruption, and a national debate every March and November. The idea of manipulating time seasonally isn't new. Ancient civilizations often adjusted their daily schedules based on sunlight. Romans, for example, used water clocks with different hourly lengths depending on the season. But they didn't change the clocks, they changed how long the hours lasted. Modern DST, on the other hand, involves changing the clocks themselves, artificially, as if time were a set of blinds we could pull up and down. The first formal proposal for daylight saving time came in 1895 from George Vernon Hudson, a New Zealand entomologist who wanted more daylight in the evening to collect insects. Yes, we change our clocks because one guy really wanted to look at bugs after dinner. The idea gained more traction a few years later when British builder William Willett published a pamphlet titled The Waste of Daylight, suggesting that people were sleeping through valuable morning sunshine in the summer. Willett, by the way, was the great-great-grandfather of Coldplay's Chris Martin, proving that causing national division over vague ideas runs in the family. Despite these early pitches, no one rushed to adopt DST. Then came World War I, and suddenly conserving fuel became a national priority. Germany was the first country to implement daylight saving time in 1916, hoping to reduce the need for artificial lighting in the evening. Britain, the United States, and others soon followed, though the results were mixed. After the war, most countries abandoned the idea. It was too confusing, too unpopular. People didn't like being told that their clocks, those sacred instruments of routine, had to lie twice a year. But daylight saving time wasn't done with us yet. It returned during World War II for similar reasons: energy conservation and national coordination. After the war, it became a regional issue. Some US states and cities adopted DST, others didn't. This led to what historians affectionately call the time chaos era, where neighboring towns could be on completely different schedules. You could drive for 20 minutes and lose or gain an hour, depending on which grocery store you visited. In 1966, the United States passed the Uniform Time Act, standardizing the start and end dates for DST across the country, except, of course, for the places that opted out entirely. Arizona, for instance, decided it had enough sunlight already and wanted no part in this temporal trickery. Hawaii said the whole thing was unnecessary, and other regions, like certain parts of Indiana, chose their own adventures. So here we are today, living in a world where twice a year, millions of people change their clocks because of a tradition that began with insect collecting and war rationing. Every March, we spring forward and lose an hour. Every November, we fall back and get it back, like an odd little daylight refund. But does it actually work? That depends on what work means. If the goal is to confuse people, disrupt sleep, and cause a spike in calendar-related arguments, then yes, DST is a rousing success. But if the goal is to save energy, boost productivity, or improve quality of life, the evidence is less convincing. Multiple studies have looked at whether DST reduces energy consumption. The results are underwhelming. While it may reduce the need for lighting in the evening, it often increases demand for heating in the morning and air conditioning later in the day. One Department of Energy study in the US found a negligible 0.03% reduction in electricity use. That's not exactly a victory parade. Meanwhile, the health effects are real. When we spring forward, sleep experts report increases in heart attacks, strokes, car accidents, and workplace injuries. all linked to the sudden loss of 1 hour of sleep. It's like the entire population collectively stubs its toe and spends a week limping. Even the productivity gains are debatable. Some businesses argue that longer evening daylight hours boost spending in retail and recreation. Others point out that groggy workers aren't exactly a recipe for efficiency. One study even found that daylight saving time costs the US economy hundreds of millions of dollars per year in lost productivity and schedule disruptions. And yet we persist. Why? Partly because change is hard, partly because traditions are sticky, and partly because DST has settled into the cultural wallpaper. Twice a year, we grumble, we change our clocks, and we carry on. Like seasonal amnesia, there have been efforts to end it. In 2019, the European Union voted to abolish mandatory daylight saving time, though implementation has been slow. In the United States, several states have passed legislation to make DST permanent. No more changing clocks, just a fixed year-round time. But federal law still stands in the way, and consensus remains elusive. And so, for now, we continue this biannual ritual. Setting alarms earlier, changing microwave displays, and trying to remember if we're gaining or losing sleep this time. It's a uniquely human thing, really, to invent time zones, divide our days, label our minutes, and then seasonally distort them like a funhouse mirror, all in the name of efficiency, or perhaps tradition, or maybe just momentum. Once you've been doing something long enough, even the absurd starts to feel inevitable. Still, there's something oddly charming about it, like a prank we play on ourselves twice a year, just to prove we're still paying attention. And in that spirit, if you're listening to this just after a time change, and you're feeling a little off, a little sleepy, a little uncertain of what hour it actually is, know that you're not alone. Millions of people are blinking at their microwaves and resetting their wall clocks too, all trying to resync their lives with the strange dance of artificial daylight. But for those who truly wanted precision, for whom mere hours, minutes, and seconds weren't enough, another kind of timekeeping was needed, something beyond the wobbling clocks of towns and the guesswork of global zones. Something so precise it could measure not just the passing of time, but the vibrations of atoms themselves. A new era was about to begin, one where time became less of a suggestion and more of a frequency. If there's one thing humanity excels at, it's taking something simple and relentlessly refining it until it's mind-bogglingly complex. We once told time by watching shadows stretch across dirt. Then came sundials, water clocks, pendulums, gears, minute hands, time zones, and the collective trauma of daylight saving time. But apparently that still wasn't enough. We wanted more precision, more regularity. We needed a clock that didn't care about weather, seasons, gears, or the emotional stability of a clockkeeper with too many keys. And so we turned to atoms. The atomic clock is, on the surface, a deeply unromantic machine. It has no hands, no tick-tock sound, no brass wheels gently humming in rhythm. Instead, it listens to the vibrations of atoms. Invisible, relentless, impossibly fast. And in those vibrations, we found what might be the most accurate heartbeat time has ever had. Let's start with cesium, specifically cesium-133. This silvery metal isn't famous in most circles. It doesn't glow like uranium or float like helium. But cesium has one very special trait. Its atoms vibrate at a consistent, stable frequency when exposed to certain kinds of energy. In fact, cesium atoms oscillate, or resonate, exactly 9,192,631,770 times per second when stimulated just right. This number isn't rounded. It isn't estimated. It is, by definition, the number of vibrations that make up 1 second. That's not poetic language. It's literal. Since 1967, the official definition of the second has been the duration of 9,192,631,770 periods of the radiation corresponding to the transition between two hyperfine levels of the ground state of the cesium-133 atom. In short, time itself, at least in our modern measurements, is based on atoms having a tiny little mood swing 9 billion times in a row. How do we count those vibrations? Very carefully. Atomic clocks use a beam of microwaves to interact with cesium atoms in a vacuum chamber. When the frequency of the microwave beam perfectly matches the natural frequency of the cesium transition, the atoms respond in a way that can be measured. The system adjusts the beam constantly to stay in sync. That resonance, that precise atomic-level rhythm, becomes the standard. It's not just accurate, it's absurdly accurate. A modern cesium atomic clock can stay accurate to within 1 second over 100 million years. Some newer optical atomic clocks, which use other atoms like strontium or ytterbium, could be off by less than 1 second over the entire age of the universe. That's right. If you started one at the Big Bang and checked it today, it might still be right. Or at least close enough to annoy philosophers. Why would we need a clock that precise? It's not for making toast. Your morning bagel will not benefit from nanosecond-level synchronization. But atomic clocks are crucial for systems that depend on extreme timing precision, especially GPS. Global positioning systems work by having satellites broadcast their exact position and the exact time the signal was sent. Your phone or GPS device receives these signals from multiple satellites and compares the timestamps. Because radio waves travel at a known speed, the time delay tells your device how far away each satellite is. With a few comparisons, it triangulates your position. Here's the catch. If your clock is off by even a millionth of a second, your location can be off by hundreds of meters. Atomic clocks ensure that those signals are synchronized down to the tiniest fraction of a second. Without them, your map app would place you somewhere between the grocery store and, say, a parking lot in a neighboring town. Beyond GPS, atomic clocks also enable scientific experiments that would otherwise be impossible. Physicists studying quantum mechanics, astronomers measuring distant signals, researchers testing the limits of relativity. All depend on clocks that don't drift, don't wobble, and don't care whether it's cloudy outside. Atomic time also underpins the internet. Financial transactions, data packets, even streaming services all rely on timestamps and synchronization. Every moment you browse, click, or scroll is built atop a scaffold of shared timing, orchestrated quietly by a global network of ticking atoms. These clocks are housed in national laboratories and metrology institutes, places with thick walls, quiet halls, and a deep respect for the number 9 billion. Countries synchronize their atomic clocks with each other regularly, contributing to a worldwide time standard called International Atomic Time, or TAI. TAI is a weighted average of over 400 atomic clocks around the world, stitched together to form a global heartbeat. From TAI, we get Coordinated Universal Time, UTC, the time standard used for civil purposes. It's what runs your computer, your airline schedule, your wristwatch, and your smart toaster. Assuming your toaster is smarter than average. But even this is a bit of a balancing act. Atomic time, left to its own devices, is too perfect. The Earth, as it turns out, is not. Our planet wobbles. It slows down. It gets nudged by tides, tectonic shifts, and lunar gravity. And because UTC is supposed to reflect both atomic precision and Earth's rotation, we occasionally need to fudge the numbers. That's where leap seconds come in. A leap second is added, or theoretically subtracted, to keep UTC within 0.9 seconds of astronomical time. These leap seconds are announced occasionally, often on New Year's Eve, with all the excitement of a very slow countdown. 10, 9, 8, 7, 6. Wait. 6 again. They've caused problems too. Some digital systems don't know what to do with a 61-second minute. Software crashes, servers hiccup. Some companies now choose to smear the leap second across many hours, stretching time ever so slightly so no one notices, which frankly is poetic. We invented a perfect clock, only to stretch and bend it so it could keep up with our imperfect planet. And in this pursuit of precision, we've entered the realm of hypertime. Time measured so finely that it can detect the tiniest distortions in gravity. The mere act of standing a foot higher off the ground, say at the top of a staircase, actually affects how fast time moves for you. Atomic clocks are sensitive enough to measure that. Time isn't just ticking, it's flexing. We're now in an era where time isn't just measured, it's mapped, modeled, watched so closely that even the smallest changes can be spotted. And in the process, we've turned time from a rough human concept into a physical quantity, something that bends, warps, and reacts to speed and space. Which brings us to something even more mind-bending, the fact that time, as we experience it, isn't universal. It isn't absolute. The more you look at it, the more it wobbles. Because Albert Einstein had a few thoughts on that. thoughts that would change everything we assumed about time. Not only did he say that clocks tick differently depending on how fast you're going, he also suggested that time itself bends near massive objects. It's a strange idea. That time, this thing we measure so obsessively, isn't fixed, that it can stretch and contract like taffy, all depending on where you are and how you move. And yet, every GPS signal, every space probe, every physics experiment quietly confirms it. Time is not a ruler. It's more like a rubber band, or maybe a ripple in the fabric of the universe. Next, we'll explore how Einstein took time off its pedestal and turned it into something dynamic, something personal, not just a tick-tock, but a bendable thread. A sleepy voyage into the world of relativity is just ahead. For centuries, time was treated as a constant, a fixed backdrop, like a stage on which the universe performed its play. No matter what happened, no matter how you moved, where you stood, or what you did, time just kept ticking, steady and impartial, like an endlessly patient stage manager. And then Einstein came along and yanked the curtain. He didn't just suggest a tweak. He proposed a total rethink. Time, he said, was not fixed, not universal, not the same for everyone. It could stretch, it could compress, it could pass at different rates depending on how fast you moved or how close you were to something heavy, like a planet or a star or a very opinionated cat. This idea is called time dilation, and while it sounds like science fiction, it's not. It's real, it's been proven, and it's woven into the very fabric of how we now understand space, speed, and gravity. Let's unpack it slowly. In 1905, Albert Einstein published his theory of special relativity. One of its key ideas was that the speed of light is always constant, about 299,792,458 meters per second, no matter how fast you're moving. This was weird because we usually expect speeds to add up. If you're walking at 5 km/h on a train, moving at 100 km/h, your speed relative to the ground is 105 km/h. But light doesn't play by those rules. Instead, something else has to give. And what gives is time. Einstein realized that if the speed of light is constant for everyone, then time itself must bend to make that true. The faster you move, the slower time ticks for you, relative to someone who's standing still. This isn't metaphor, it's measurable. Imagine two twins. One stays on Earth, the other boards a spaceship and zips off at near light speed for a few years. When the traveling twin returns, they'll be younger than the one who stayed home. Not by a feeling or a trick of memory, but literally, biologically, clock on the wall younger. This is called the twin paradox, and it's one of the most famous thought experiments in physics. And while we don't currently have spaceships capable of approaching the speed of light, or twins legally cleared for orbital deployment, we've seen time dilation in action. Satellites in orbit, for example, experience time slightly differently than we do on the ground. Their onboard atomic clocks tick just a tiny bit faster. Why? Because they're moving quickly, which should slow time. But they're also farther from Earth's gravitational pull, which speeds time up. In their case, the weaker gravity wins. And that brings us to Einstein's second big insight, general relativity, published in 1915. This theory extended his earlier work by adding gravity to the mix. It said that massive objects, like planets, stars, and very large fruitcakes, warp the space around them. And because space and time are linked, this warping also affects time. In other words, time passes more slowly the closer you are to something massive. If you stand near a black hole, time would crawl for you compared to someone lounging on a sunny beach far, far away. Not that we recommend black hole tourism, but it's good to know your options. This idea has been tested in real life. In 1971, scientists put atomic clocks on airplanes and flew them around the world. When the planes landed, the airborne clocks were slightly out of sync with identical clocks that had stayed on the ground, exactly as predicted by relativity. Even the GPS system, that gentle voice that tells you to turn left in 200 meters, relies on corrections for time dilation. The satellites are moving fast and are far from Earth's surface, so their clocks tick faster than ours. Engineers have to adjust for this constantly. If they didn't, your GPS location would drift by several kilometers per day, which, while charming, would make it hard to find your favorite coffee shop. On a human scale, these time differences are tiny. We're talking nanoseconds, nothing you'd notice while brushing your teeth. But on a cosmic scale, across galaxies, black holes, or high-speed space travel, the effects add up. Time isn't just the same everywhere. It's elastic, personal, relative. It's a bit like a river that doesn't flow at a uniform speed. In some places, it rushes. In others, it trickles. And where gravity is strongest, or motion is fastest, time flows more slowly. Like thick syrup, reluctant to leave the bottle. This also means there's no such thing as a single, universal now. Two events that happen at the same time in one place might not be simultaneous for someone moving quickly through space. Now becomes fuzzy, stretchable, more of a suggestion than a rule. And that's deeply weird, but also kind of freeing. It tells us that our experience of time, as this constant, unwavering march, is not the only perspective. There are other timelines, other rhythms, other clocks ticking slightly out of sync. The universe is not bound to our calendar or our sense of just in time. It's full of soft disagreements. Time, in this view, is not a ruler or a stopwatch. It's part of the shape of reality, bent and twisted by mass and motion, flowing unevenly across the contours of space. And that's a lovely thought in a way. It means time is not a tyrant. It's not out to get you. It's not running away. It's just stretching, flexing, curling around stars and drifting between atoms. We are, all of us, surfing a slow wave through space-time. Some parts of the wave ripple faster, some slower. And while our clocks try their best to keep up, they are always approximating, chasing an illusion of sameness in a universe that never quite repeats itself. Of course, for most of us, these differences are theoretical. You're unlikely to age slower because of your morning jog. But the fact remains, the faster you go and the stronger the gravity you're near, the weirder time becomes. This knowledge doesn't change your daily routine, but it does shift how you see it. The ticking of your watch, the vibration of your phone, the countdown on your microwave, all of it is based on assumptions about time's pace. And yet those assumptions are always slightly wrong, slightly wobbly, because time, in the end, isn't a perfect grid. It's a flexible thread, and every once in a while, that thread slips, because our systems can't quite keep up. Clocks disagree, calendars misfire, and humans, in their well-meaning quest to organize the universe, have to admit, sometimes we need to skip a beat, or a second, or even, on rare occasions, an entire day. Because while we've bent time with relativity, we've also bent it with bureaucracy. And next, we'll explore what happens when humans aren't around to keep time. What happens when the clocks are silent, the calendar's forgotten, and the leap seconds no longer needed? In the next chapter, we'll let go of our need for order and explore time as it exists without us. Let's imagine, just for a moment, a world without clocks. No ticking, no schedules, no alarms or appointments or quarterly calendars, no atomic pulses humming under your phone screen, no New Year's countdowns or time zone math. The Earth still spins, of course. The sun still rises and sets. But no one is counting how many rotations that's been. No one declares it's Monday at 3:42. The sky just moves. The stars shift. The seasons roll forward like a slow tide. In this world, time still exists, but it is not kept. It is not stored in databases or printed on train tickets. It is simply felt, lived, reacted to. And oddly enough, much of life already does this. Long before humans devised their calendars and clocks, living things were already experts in timing. Plants, animals, fungi, all follow rhythms older than sundials, deeper than any ticking wristwatch. These are biological clocks, internal, invisible, and astonishingly precise. Take, for instance, the humble circadian rhythm, from the Latin circadium, meaning about a day. Almost all living organisms have one. It's a roughly 24-hour cycle that governs everything from sleep and hunger to body temperature and hormone levels. It's why you feel sleepy at night, even without looking at a clock. It's why jet lag exists. Your body isn't just confused about location, it's confused about when it thinks it is. This rhythm is controlled by a tiny region in your brain called the suprachiasmatic nucleus, the SCN, if you're on familiar terms. It's located in the hypothalamus, just above the optic nerves, which is convenient because the SCN gets its cues from light. When your eyes detect morning light, the SCN resets your body's internal clock, like a rooster but squishier. And you're not alone in this. Plants have circadian rhythms too. They know when to open their leaves, when to release scent, when to grow, and when to rest. Some flowers close at night and reopen in the morning. Others bloom only once per year with eerie punctuality. The moonflower, for example, waits until twilight to unfold its petals, as if it has a tiny sundial hidden in its roots. Even algae, microscopic, simple algae, follow circadian cycles. Their photosynthesis slows down at night. They rest. In a world without watches, these tiny organisms still keep time. But biological clocks go beyond the daily rhythm. There are seasonal clocks too, rhythms that unfold over weeks, months, or years. Trees, for instance, track the length of daylight to know when to drop their leaves. As autumn darkens, they slowly pull nutrients back into their roots, preparing for the stillness of winter. When spring returns, they bloom again, not because a calendar told them, but because light whispered it was time. Animals feel these changes as well. Birds migrate, bears hibernate, foxes grow thicker coats. Sea turtles crawl ashore by moonlight to lay eggs on the same beaches where they themselves were born. All without a smartphone reminder. Hibernation itself is a masterpiece of biological timing. Bears, groundhogs, hedgehogs, they prepare all year, sensing subtle cues from temperature and light. Then, at the appointed time, their metabolism slows. Their heart rate drops. They drift into a sleep so deep it almost defies definition. And even during hibernation, time ticks on. Cells repair. Energy burns slowly. Dreams may stir. It's not the absence of time. It's simply a different rhythm. Seeds, too, can wait. Some seeds remain dormant for years, even decades, until the conditions are just right. They sleep through droughts, fires, winters, and wars. Then, one day, with a whisper of water and warmth, they wake, as if no time had passed at all. There's a kind of wisdom in this patience, a kind of surrender. Nature doesn't count time in seconds. It feels time in cycles, in seasons, in shadows and scents and shifts in the wind. It doesn't need precision. It needs readiness. And there are creatures with clocks far stranger than ours. The mayfly, for instance, lives for only 24 hours after hatching. It has no mouth, no need to eat, just time enough to mate and vanish. A single day, perfectly timed. On the other end of the scale, there are jellyfish that may be biologically immortal, their cells capable of reverting to earlier stages of life. A reset button, hidden in gelatin. Time, in this case, becomes less a line and more a loop. Even in the ocean, the tide itself keeps time. The moon's gravity pulls and releases in a rhythm older than civilization. Crabs know it. Corals know it. Fishermen once knew it too, long before weather apps began predicting the waves. So what does all of this tell us? That time does not belong to humans. We may label it, dissect it, and digitize it. But long before we drew numbers in sand or etched marks on bones, life was already following the pulse of the universe, quietly, gracefully, and without asking what hour it was. And perhaps when we feel overwhelmed by clocks and deadlines, when the numbers blur and the schedules stretch, it helps to remember that we too are part of this older rhythm. You are not a machine. You are not made of ticking parts. You are part of a world that breathes in cycles, that grows in spirals, that sleeps and wakes with the rise and fall of stars. Sometimes, the most natural thing you can do is to stop measuring, to rest, to nap when you're tired, to step outside and feel the sun not as a timekeeper, but as warmth. The truth is, we built our systems of time because we had to navigate, to trade, to cooperate. But the body does not care about coordinated universal time. Your cells are not checking the hour. They're just doing their jobs, one moment at a time. And maybe that's enough. Maybe, in the grand quiet of nature, time is not a commandment, but a hum, a soft rhythm in the background, a lullaby of motion. Because whether you're a bear dreaming in a cave, a seed waiting in the soil, or a human listening gently in the dark, time will carry you. There's nothing to catch up to, nothing to chase, just the soft procession of moments, one after another, like footsteps in snow. In the final part of our journey, we'll let time rest. We'll put down the clocks, hush the tick-tock, and close the story, not with a bang, but with a slow exhale. Let the clock stop for a moment, not in panic, but in peace. Let the second hand pause mid-step. Let the digital display go dark, just for tonight. Let the ticking soften, the alarms forget their jobs, the countdowns wait patiently in the corner. We've done enough for now. We've counted enough hours, chased enough deadlines, remembered enough birthdays late. It's all right. Let the gears rest. Because for the last 2 hours, we've been untangling the story of time. Slowly, curiously, a bit awkwardly at times, but always with care. We started with the feeling. That strange sense that time is both too fast and too slow, that minutes can stretch like molasses, while years vanish in a blink. We wondered, what even is this thing we keep measuring? We learned that time, as we know it, is the measurement of change, a way to notice that something is different now than it was before. A footprint, a breath, a sunrise, or just your tea going lukewarm while you weren't looking. We saw how the universe, indifferent and ancient, lays out its rhythms with stars and entropy, how time flows like a one-way river, nudged along by disorder, a cosmic push toward more messiness, not less, and how humans, ever hopeful, try to tidy up by building calendars out of chaos. We looked to the sky, following the sun and moon like curious children with sundials made of sticks. We invented weeks, months, seasons, and then argued about all of them. We blamed the moon, worshipped the sun, and consulted goats. Occasionally, with impressive confidence, we graduated from water clocks to tower clocks, from pendulums to cesium beams. We got good at ticking. Very good. So good that we now measure time with atoms that never blink, never wander, never daydream about sandwiches in the middle of the workday. We split seconds into slivers. We tracked time so precisely that a foot of elevation could shift it. Time became a ladder we could climb, a ripple we could ride, a thread we could stretch. And as we stretched it, we bent it. Einstein showed us that time isn't flat. It warps near gravity, slows with speed, stutters near black holes. It's elastic, personal, relative. Not a universal drumbeat, but a soft, syncopated rhythm. Different for each traveler. We built leap years to catch up to the sun. We built leap seconds to catch up to the earth. We once deleted entire days to fix a miscalculation, as if time were a spreadsheet we could tidy. And sometimes it worked. Other times, it just made February feel insulted. But while our inventions tried to keep time in a box, nature kept ignoring us. Bears hibernated. Flowers bloomed. Trees yawned their way through centuries. The moon pulled the tides without asking permission. And somewhere in the dirt, a seed waited patiently for its moment to begin. Time was never ours to command. We were simply trying to befriend it. And maybe that's the most beautiful part. That in all our clumsy attempts to pin down time, to slice it, divide it, tame it, we created stories, calendars full of meaning, clocks that chimed with poetry, holidays and rituals and naps scheduled precisely when they felt needed most. Timekeeping, for all its flaws, is a human form of storytelling. A way to say, this happened, and this will come again, and now it's time to rest. Because ultimately, time is a partner, not a prison. Yes, it rushes sometimes. Yes, it ambushes us with wrinkles and surprise birthdays. But it also gives us rhythms to dance to, seasons to anticipate, morning sun to wake with, evening light to sigh into. We are not at war with time. We are dancing with it. A slow, clumsy, graceful dance that takes a lifetime to learn. And at night, especially at night, we get to stop counting. The emails pause. The clocks dim. The urgent becomes less urgent. The to-do list becomes a to-don't list. This is the hour when time is softest, when the world becomes quiet enough to hear your own heartbeat, when seconds lose their sharp edges, when you are allowed, invited, even, to let go of precision. So tonight, let the seconds stretch. Let them flow like warm honey over a quiet mind. Let the hands of the clock rest. Let the gears unwind. Let the atomic pulses keep ticking, far away in laboratories you don't need to visit. They'll keep track for you. Tonight is not about measuring, it's about feeling. Feeling the weight leave your shoulders, feeling the breath slow, feeling the bed cradle you like. The earth cradles the moon. Gently, rhythmically, always. You've wandered through a vast landscape of seconds, days, epochs. You've watched atoms vibrate, galaxies drift, calendars collapse, and scientists lose sleep over time zones. You've earned some timelessness. There is no rush. There is no late. The universe has no closing time. The stars are still spinning whether you set your alarm or not. So close your eyes, or keep them half open if that's your style. Let the dark settle around you like a soft quilt. Let the stories of time dissolve into dreams. And if you must keep something, keep this. Time is not just numbers. It is warmth, change, presence. It is a series of nows strung together like pearls. You are in one of those nows, and it's a good one. So let the clock stop. Let the seconds drift. Let the night unfold slowly without deadlines, and let yourself sleep.